Hello and welcome to class again. Now, previously we've been talking about, or so far we've been dealing with the topic, the laws of indices. Indices, actually, we'll consider the laws. Now, previously in the last videos, we looked at the laws of indices and we defined this. That this is the law governing powers and exponents. And then we also went forward to looking into the various laws. The product law, which states that a number raised to a certain another number, in which case we looked at. Now, first we defined the terms quotient and product, and what quotient, product, and what exponent means. Now you can check the previous videos so you get to see these things. Now look at the product rule, the quotient rule, the power of a power rule, and also the power of a quotient rule. Then in another video we'll consider the power of a product rule, the zero power rule, and the negative power rule, and the functional power rule. Now, because of time and considering the length of the videos, I would have gone into each one of them one by one, but as we continue today, as you can see, we'll be having in our class, we'll be considering each, or we'll be taking questions, we'll be solving it. Now, having done this, what we'll be doing by the time we'll be solving the questions, we'll be making a combination of these rules. So in the process, you'll get to understand these things. So let's delve in quickly. So we'll pick the first question. The first one is this. We'll solve them one by one. And the first will have 32 raised to the power of 105. Now this question falls in the fractional power rule. That is the power. This is the exponent, or called power. Exponent is also referred to, the power is also referred to as exponent, is a fraction. Now normally you can have a whole number being a fraction, being a whole number like 2 or 4 or maybe 6 being the exponent. But in this case, when you have a fraction, now the rule simply states that when you have a fraction, the denominator will form the root while the numerator will form the power. Now that means we're going to have it as 32 raised to the power of 1, and the denominator, raised to the power of 1, the denominator will form the root. So this is going to be the fifth root of 32. Now, but first of all, let's do this. What is 32 raised to the power of 1? It means write 32 one time. If I'm to write 32 one time, it's going to be 32. So I'm not writing it twice. I'm not multiplying it by itself. So this is it. So this is going to still be the fifth root of 32. Now, what's the fifth root of 32? The fifth root means you look for a number that number you multiply by itself 5 different times to give you 32. Now, if we take 1 times 1 times 1 times 1 times 1, 1 times 1 is 1, times 1 is 1, times 1 is 1, times 1 is 1, so we have 1. Well, let's try the next number, 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5. So now we'll have 2 times 2 is what? 4. 4 times 2 is going to give us 8. 8 times 2 is going to give us 16, and 16 times 2 will give us 32. So the number is actually 2. So the number, the fifth root of 32 is actually 2. So this solves it. In other words, therefore 32 raised to the power of 1/5 equals to 2. This is the answer. Now we'll quickly go to the next question. The next question is almost like the same. 27 raised to the power of 2/3 is still on this fractional power rule. Now this rule states that the denominator forms the root while the numerator forms the power, that is exponent. Now let's go just like this. You have it as the cube root of 27 raised to the power of 2. Now, this is still the same thing. Now, 2/3 is still the same thing as 1. We can pull it, just like standing this way, and then I pull it out separately. If I pull it out, it's still the same thing as saying 1/3 times 2/1. I'll just pull them apart. Pull them apart. So this is the same thing as saying 1/3 times 2/1. If I multiply it, I will get this again. So 1 times 2 is 2, and 3 times 1 is what? 3. So you have it this way. Now, if you look at it this way, it's the same thing as saying 27 all over 2, all over 1/3, and then bracket 2 all over 1. The bracket means the times. So 1 times 2 is still 2, 3 times 1 is still 3. So this one, from the fractional rule, this one forms the root, while the numerator 2 forms the power. Now, from this we go ahead straight. Now, let's reduce it first because it's going to be a lot easier. If you square this, the number will become so bogus, it will become difficult for you. I always advise people to make it in such a way that it's going to be smaller for you. So the cube root of 27 first is looking at that number. There is a number that when you multiply by itself 3 times, is going to give you 27. What is that number? That number, let's start with 1. 1 times 1 times 1. And 1 times 1 is 1 times 1 is 1. Another is 2. Let's try 2. 2 times 2 times 2. 2 times 2 is 4 times 4. And times 2, 8. It's not going to be 7. Let's try 3. 3 times 3 times 3. Now 3 times 3 is what? 9. 9 times 3, 27. In other words, the cube root of 27 is 3. So 3 is the number. So by the time we find the cube root of this, we'll have it as this, as the cube root of 27 is 3. But remember, I've not done anything with this square, so the square still remains. So 3 squared means what? 3 squared means 3 times 3. Write 3 2 times. 3 times 3 and 3 times 3 is what? 9. So this is the final answer for this. So in other words, 27 to the fractional power of 2/3 is the same thing as 9. Right? Now, the next question, if we have the time, is 3. 4 raised to the power of minus 3 over 2. Now, with this is a negative. It's still the same thing. Negative power rule, negative fractional power rule. So it's not going to be like this. And there's a rule that says that if you have it, it's going to be reciprocal. Now it's going to be this is what we're going to have. The power of a negative exponent. Good. This is how I'm going to put it. The power of a negative exponent. Now, you can read maths like English. Now, I've said this previously that the problem of maths is English. If you understand English, you can go this way, take maths this way, and take it this way. They can present a question like this, and a question, you will read it like English, like you're reading a book. Now, this is a negative power or power of a negative exponent. The exponent is a power. Yes. So let's go ahead. From this, I'll have it. This is going to form a reciprocal. It's going to be as this. Please understand. 4 raised to the power. The minus sign is reciprocal, meaning it's going to be 1 over 4. And the power will now remain 3 over 2. That's how it's going to be. Now, if we go on, remember the rule still states that this will form, the numerator will form the power, while the denominator will form the roots. Now, this will give us, this is the same thing as we had, square root of, we still have our reciprocal first, and then 3. Now we do not need to put square. Normally we don't put square here. So we just have it as this. Now writing it out, we have 1 to the power of 2, or the square root of 4 to the power of 3. Now first let's do the square root, bring it down before we do it. If you raise it up to the cube, it might be difficult to do the work. So what's the square root of 4? We still have a reciprocal. The square root of 4 is the number that you multiply by itself 2 times to give you 4. And of course we start with 1. 1 times 1 will give us 1. And then 2 times 2 will give us 4. So that means the number is actually 2. So the square root of 4 is 2. Now we will not use this 3. This 3 still remains. We've only succeeded in taking this square root sign away. The square root sign is off because we've done the square root of this. So what is now going to be the power? What is 2 raised to power 3 is the same thing as saying 2 times 2 times 2. That is, write 2 3 times. 2 times 2 is 4. 4 times 2 is what? 8. So what we have is 1 all over 8. Now some people will see 2 raised to power 3 and just say it is 6. No. What they've done is 2 times 3, 6. No. But it is 2 raised to power 3. It means 2 times 2 times 2. That is 8. What you have here is this 1 over 8. I can take it back to be as this. This is the final answer. It can also be written as 8 exponent, negative exponent. Now, having done this, in the next class, but before we go to the next class, I'd like you to try your hands on this. This is very simple, straight to the point. Just observe the rule and you get it. Now, I want to do this, so I don't get to do everything. You've been in the previous classes. If you missed it, go to the back and then you see these things. I want to thank you for staying tuned. Like, subscribe, follow. Thank you.